Hello and welcome to another episode of the Kab Python series. This is episode 15. My name is Simon, and in this episode, we are going to be looking at exception handling, or what can be called error handling in Python. Error handling is not only in Python, but in most of other programming languages, it is there, and it is a very crucial concept as we are going to see. So, we are saying that it is a mechanism to handle runtime errors or exceptional conditions in a program, allowing for a smooth execution flow. So, uh, I know most of you have used mobile money, and there's a point where they ask you to enter the amount of money to withdraw. So I want you to imagine the system requests you to enter the amount of money to withdraw. And instead of putting an integer like 20,000, you put a string. Maybe you write 20,000 in words. So that's not what the system expects. And if that system will surely print for you an error, it will crash because it has gotten something it was not expecting while running. That's what we call a runtime error. I will not be covering types of errors in this video, but there are errors like syntax errors. That's when you violated the rules or the syntax. We have runtime errors. These are the errors that occur when the program is running. For example, that one, it expects you to put a certain input, but then you put what's not expected. That is a runtime error, and those are the type of errors that we shall be talking more about when we talk about exception handling, although we can also handle syntax errors also somewhere. So when the system expects you to enter money in an integer value, and then you enter a string, it will raise for you an error and the system will crash. So that's what we are trying to avoid. How can you avoid the system from crashing if the user enters what is not expected of him? How do you handle that smoothly and the program keeps running without crashing? Then another way, if that error has occurred, how can we notify the user of what the error was in a way that the user can understand? Because our text editors here, like you see, they normally display errors that are not that require someone who has the technical knowledge to understand what the error is. But then we develop these systems for people who may or may not have that technical knowledge. So we need to consider that when we are developing our systems so that everyone can use them with ease. Okay, so should I? Okay, wait a minute. So why do we do exception handling? Like I said, we do it to prevent program crash, to maintain the flow of the program, and to find a way to catch and manage unexpected events. Okay, so the common Python exceptions which we have what we call the zero division error. This one is raised when a division by zero occurs. Maybe in your system somewhere, somehow, you have something like, okay, I have this program here, I have the variable x, y, and now here I'm printing the result where I'm dividing the two. So when I save this and run, you can see the result here is 3. When I divide x by y, I get 3. But now let me change. Instead of doing that, so this is here the program has run the way it was expected to, and there is no error. So let me try to divide by 0. I want to see how the zero division error occurs. Did I save this? Okay, let me call this .py. Okay. So, okay, just a minute. Just a minute. So here we have other errors that we are also going to jump into and look at. like the name error, value error, index error, key error, and we shall see them practically, how they occur and how to catch them and prevent them from causing program crash. So here we are having this. We're trying to see how a zero division error occurs. So when I run this, okay, it is running. Is running. I'm dividing by 0. I want to see. Okay, I hope you can see. So this kind of error is very dirty, and if your program is running or your software is running, and then such an error is displayed to the user may not easily understand this. It looks very not good, and we should have a systematic way of displaying this error, because you can see now even the program has stopped running from there. Let's say, for example, I had some other code that I wanted to run here. Maybe I wanted to get some input from the user after this. Maybe I wanted to get some input from the user after this. Enter a number. Maybe I wanted to get an input from the user after this. Let me save this and run it again. You see what has happened. The program on running, this line is okay. This line 2 is okay. But on line 3, like it's stating here, there is an error. There is a zero division error because you cannot divide by 0. So because of that, the program has crashed. You can see that line 4, the program has not interpreted line 4 just because it has crashed after encountering this error here. So we should handle this error so that the program can move on and do and proceed with execution even though there is an error. And on top of that, we should display an error message that the user of our system can understand and know how to deal with that. So let's try to handle this zero division error. Let's see how we can handle it. To handle it, we have what we call the try and except block for catching those errors. So the whole of our code, we write it in the try code. And then we have the exception part to handle the exception. So I want you to take this concept of try and except the way you understood if and else. So you can take try to be if and except to be else. Try means if the program has no errors, then the code inside the try part will run successfully. And then except means except if there is an error, then the code that you put here is what will run. So let's see how to handle this error. What I'll do, I'll cut all this code like that. Then I put my try block here. I'll say try, then paste it here. Okay, let me do this. Okay, now it has been indented well. So when you're using the try block, the same way we indent when using if, you should also follow the same method. After the try, after this colon here, the block for the try, the code block for the try part should be indented from this level. So everything that is written from this level falls within the try block. Then we are saying that if the program does not have any error, then it should run. Then this code here should run. All this code here should run successfully if there is no error. But if there is an error, it should have an except block. That's why you see this underlined here. It is waiting for me to put the except block because unlike the if, here you can't have only the try block. You need to have except. So I'm saying, except if there is an error, then this is what you should do when there is an error with my program. So if there is an error, you should print, like for this case, we are having a zero division error. So you should print a message to the user and tell him that you cannot divide by 0. Yeah, this can be descriptive enough, or you can make it a little bit more descriptive for the user. When I save this and run, you see now we are not having the other dirty stuff we had the other time. And we are now having something you cannot divide by 0. So this is, a user can understand that I divided by 0 and it is not allowed. I have to divide with something that is not a 0. So that this code has run inside the except block because there was an error. If there was no error, then this code here was going to run. Let me put y here. You can see now it has passed this line now. There was no error on this line 4. It is now proceeding to line 5 and it's asking me to enter a number. And I enter a number like 4. You're seeing it has printed the result of 12 divided by 4, which is 3. So if there is no error, the code will run successfully. The code under the try block. And if there is an error, you put your error in the except block. So that is that. Okay, handling multiple errors. Then we can also have a name error. Let me first handle the name error. Name error occurs when a variable or object is not defined in Python. When you have an object that is not defined, or a variable that you're trying to access, but then it is not defined, you always get that name error. For example, here, let me try to say, there's something I want to demonstrate still with this. I'm doing it intentionally. Okay, let me say x divided by z. You can even see z has been underlined already, showing you that the program will run, but there is that error there that you have to check. So you're seeing the error we are having is you cannot divide by 0. So this is not displaying the error that we are supposed to be having. The error that we are supposed to be having is you have an undefined variable. You have a variable that is not defined, because we are using z, but then z is not defined. So that is the error that we are supposed to have. We have that a variable that is not defined. So you can see that using except without specifying the type of error that you want to catch, you won't have something that works efficiently. So that is why we have this part here. You're supposed to include the type of exception that you want to handle. So if you do that, we can even catch multiple exceptions at a go. We can catch, let's come back here. So let me put back the 0 here, and then let me do undo. Okay, so this is meant for catching. If this is meant, this except block here, if it is meant for catching the error when you are dividing by 0, it means I should specify it here. Except, then I write 0. You write the type of the error. Before I finish it, it is even there. You should note the way how these types of errors are written. You can see zero division error. Z is capitalized, D capitalized, and E capitalized. That is how these errors are named in programming. So if the program meets that you have a variable, you try to divide by 0 somewhere, this exception will be thrown. Then we can catch another exception, maybe except what were we doing here? We had a name error. When you accessing a variable that is not defined. If you meet that, then it will print for you you have an object that is not defined. You have an object that is not defined. So here it will catch two errors at a go. You can have it catch as more errors as you wish it to. So for this case, it will have to catch this zero division errors. I'm dividing by zero here. Let me save and run. Okay, it's running. Let's wait a minute. Just a minute, it is running, but we should be able to get what the output is. So you can catch multiple errors or exceptions with the same just by using except, then you put the type of error that you wish to handle. Then you put except the error that you wish to handle, and you keep doing that to handle all the errors that you expect to happen when this program is ran. So you're seeing here we are having, you cannot divide by 0. So let me have it here, x divided by z. So this time I am using z, but z is not defined anywhere. By defined, we mean now x is defined because x equals to 12. That is defining x. If y, what is y? Y has been defined in my program that y equals to 4. That is what we mean by defining an object or a variable. But z is not defined somewhere. But then out of nowhere, I'm saying divide x by z. So z is not defined. That's why we expect that error to be raised somewhere. Okay. So the other time, this block of code was the one which was executed. You cannot divide by 0. By this time now, that error does not exist. Instead, you have an object that is not defined, which is this z here. So if we deal with that, maybe we now try to define z. Z equals to 3. And when we save and run, now our program should be, now our program is running as expected. You can put here a 2, and there we go. So, hope you have seen how that works. Then another error, we have what we call a value error. This one is raised when a function receives an argument of the right type, but an inappropriate value. For example, this one here. When we're having m input, m is a variable which is expecting a value from the user, and that value should be an integer from the user. So if you enter a string, what will happen? Let's try to run this code again, and we give it a string. Maybe this is now the mobile money thing. It is expecting you to enter the amount of money you wish to withdraw. Then you're entering hash, you're entering some other funny things. So let me enter something that's not an integer like that. You see, that is an error there occurring. You're seeing value error. So that is the type of error that happens when a function, this int here is a function. It is an inbuilt function. Even your defined function can also have the same whatever. So it is expecting an integer, but then you're giving it a hash, that is a character. That's not what it expected. And that's why it is throwing something like this. So imagine you are using your mobile money app and you encountered something like this. Would you understand that you put an incorrect figure? You literally wouldn't. Now, for you, you might try to figure it out because you know some bit of programming. But now you you have mercy for someone who doesn't know anything about this. What will the person do? Is seeing literal, seeing the stain, seeing some funny things. So this is not easily understandable. We need to handle this so that a user can proceed and know what exactly is wrong and deal with it well. So let's try to handle that error also. Can say except, let's now try to catch this error here, value error. So I write value error. So if a value error occurs, we should print out this message to the user. You entered an incorrect value for M. Please enter an integer value. So the user will know, oh, does it, so I entered something that is not an integer, which means I have to enter an integer. So this is understandable, and the user won't repeat that same mistake. When I save this and run it now, when I enter my hash again, you say you entered an incorrect value for M. Please enter an integer value. So I'll know what the problem was, and next time I won't repeat it. So the next time I'll now enter an integer. And just like that, the program is running quite fine. So those are value errors. Then we have what we call index errors. This one is raised when an index out of range of a sequence, like a list or tuple. So inside our try block here, I'm trying to show you that you can handle multiple errors using the same block of code, or just using the except and defining the error that you want to catch. So let me have a list of names here. Why don't I have max to 10? I'm putting max for someone's coursework. Okay, I'm storing them in a list. The person has 30 somewhere, then has 28, then has 20, this is 29, then 34, and 35. So then we all know how to access these values here. You just print, you just say print, you put max, then you define the index which you want to access. So let me see the indices here. This is 0, 1, 2, 3, and 4. So let me try to access the item at index 5. Okay, it's telling me to enter a number for index error. We are encountering an index error. List out of index, list index out of range. I'm accessing an item that is out of the range for the items that are existing in my list max. So that's what we call an index error. And we need to handle it also in a smooth way. So let's include an except block for that. I'll come down here. Okay, I'll come I'll come here and try to catch that, except index error. I want to catch that index error. And say the item you entered, the index you entered is out of range for the available items in names. Okay, in names, in Okay, let's just have that. So when such an error occurs, it should print for me that message instead of throwing in this ugly message here. Enter a number 4, and there we go. The index you entered is out of range for the available items in names. So I will know that I entered a very huge number. The items are do not go up to index 5. So when I put 4 and run my program again, put 5 here, and there we go. It has printed the item at index 4, which is 35. Okay. Then we have what we call a key error. This one is raised when a key is not found in a dictionary. This one now occurs in a dictionary. Let's have a simple dictionary here. You can have a dictionary to store student 1. We said that a dictionary, you define it like that. Then you put your key here, which is name, and then the value. The value is Johnny, okay? And then we have another key, age, and the value for age is 22. Now I want to print. We know that to print any of these keys, you just put student 1, student 1. Then inside here, you put the key, age, name. So let me put city. Maybe I don't know. Let me put city. Maybe I wanted to include it, I forgot, but then I'm trying to access it here. So I'm trying to print student 1's city of origin. And I save this and run, enter a number 5, and there we go. We have a key error, city, because I'm trying to access a key that does not exist here, but still it is in a dirty way. So because I'm just seeing key error city, what does this mean? It's not very descriptive enough. I should make it very descriptive for the user of this system to be able to identify it and handle it well. So what do? I should catch that error also somewhere down here. I should say, except if a key error occurs somewhere, if I encounter a key error, what should I do? I should print the key you entered does not exist in the dictionary. Can even be kind enough and say, please check the key you entered and try again. There we go. And I save and run, enter a number, enter 1. The key you entered does not exist in the dictionary. Please check the key you entered and try again. So I will go back and check the key I entered. Oh, I entered city. City does not exist. Let me put something that exists, something like age. And I save and run. Okay. And now we are good to go, splitting the age here. So that is that. I've looked at just a few of the errors that occur, but there are multiple of them. But this should just give you a hint of how to handle each of those errors when they occur in your program. Okay. The else and finally close. So the else clause runs if no exceptions are raised. So this one will always run if no, you can include the else block somewhere. Maybe there we can have else and we print have something like the program executed, the program executed without errors. So when you don't meet any error in your program and the program is done executing, it will always execute this else block. Let's run it and see. Put our 5 here, and there you go, the program executed without errors. Now let's put some error when we are entering that input and we put something bad. Enter a number, let's enter a string. Now there is an error there. You entered an incorrect value for m. Please enter an integer. So you see the else block is not printed here. So that is the function of the else block. Then we have what we call the finally clause. This one always runs regardless of whether an exception occurs or not. So let's put a finally. And it is telling us finally will always run whether there is an error or not. So in this space, normally we just put the code that should always run. So we can say end of program. You can have something like that in our finally clause. So let's run it when we have an error. Let's enter a valid value like 5, and we have it here. The program executed without error. This is the else block. And then end of program. This is the finally block. Let's now have an error somewhere. We enter something bad. And now we have encountered an error. You entered an incorrect value for m. Please enter an integer value. End of program. You see, else block is not printed, but finally is printed. So this one is finally is printed whether there is an error or not. Else is printed only when there is no error in your program. Hope that is fine. Then we can also create custom exceptions. We can create our own exception classes in Python. But what we do, we just have to make sure we should inherit from the exception class in Python. There is a special class in Python, inbuilt class called exception. The other time we were looking at classes and objects, we saw how to create classes. We saw how to inherit from classes that we created on our own. So here we have a chance to inherit from a class that is existing within Python called the exception class. So let's try to what can we do? Let's try to create our own custom exception class that should check whether okay, we can comment out this. So let's create our own class that should try to check whether someone has entered an incorrect value for age, because we know that age is always positive. Now, if someone enters a negative age, instead of the program just proceeding, it should throw, because that type of error is not caught anywhere. Because if let's say, let me first do this. If let's say we want a user to enter their age here, and we say age equals 2, int input, enter your age. Enter your age. So someone has the chance to enter their age there, and it is printed somewhere, or we do something with it. When I save and run, I can enter 23, and that is that. How about if I enter, -8? So it will still run well because this is okay. -8 is an integer. So for the Python, it does not see any error there. But logically, this is wrong. Age cannot be negative. So for such kind of cases where such errors may occur in your program, but then they are not handled in Python, that's when you create your own custom custom class to handle such errors. So what I'll do, I'll create a class to handle that error. Edge, we can call it edge check. We should maintain the way how Python defines the error, the classes of errors. You could see value error, index error, every word is capitalized. So you should maintain that edge is capitalized, check is capitalized. You can add on error, edge check error. Or how can we make it more descriptive? Can we call it negative edge error? Let's call it negative edge error. So we said when you're creating your own custom class, you should inherit from the exception class. So we know how to inherit. You just put the class you're inheriting from here in these brackets. So here you can just put pass. Pass is normally put when you're defining a class, but you don't have the code to put under there. Maybe you will put the implementation a little bit later on. So you just put the word pass and you proceed. So let's now start writing our program. We can have try. Then inside the try block, we now bring our code here. We are saying edge is that the user should enter that edge. And now let's try to handle that error where the user might enter a negative value for edge. So we say except negative. You see now it is also among the suggestions here, negative edge error, because we defined it up there. So let me click on it. So if you meet a negative edge error, what should you do? You should print for the user, you cannot have a negative edge. Please enter a positive value. So the user will know that they are not supposed to enter a negative value for edge and it should be positive. So next time I enter my negative 9, okay, this one printed. How did that happen? Let's try to see. Okay, just a minute. Let's try to troubleshoot this. Okay, edge. Okay. So the reason why it has raised this, it is because for it does not see anything wrong with it. This error, we are just supposed to raise it. So what we can do, let me cut all this. Let me cut all this. Then we can say, before printing this edge, can say if edge is greater than 0, okay, is less than 0. If edge is less than 0, okay, we can raise exception. Raise negative edge error. You should raise a negative edge error. So in the negative edge error, let's try to have something here. Maybe you cannot have a negative edge value. So let's get rid of this try block here. Then, okay. Let's try to do this. Okay. Save, run. Okay. Let me enter -3. Okay, it is raising negative age error, but then it is not printing the statement under that. So how can we smoothly improve this? We expect it to print, you cannot have a negative age error, but instead it's just printing here negative age error, and she's not showing us something descriptive enough. So what we can do, should we, okay, okay. Let's run again. -6, negative age error. We're still not having the message displayed. Okay. So let me cut this, then pass. Then what we shall do, I think we shall have to use a function. The same way we use the function here, we had the number, the function that checks that. So, okay, age equals to, enter your age, and then, okay, let's try to put the descriptive message here. Let's try to put it here. You cannot have a negative age. Enter a positive value. Save and run. Let me enter my -3. You cannot have a negative age. Enter a positive value. Now we are having it like we wanted. So the concept here is if you want to handle your own custom exception, that is what you do. You first of all have to define your custom exception class here, where you can put no code, and then you come and proceed with your implementation. If then you should have this if somewhere, if uh, something like this happens, someone is entering age that is negative, you should raise an exception, negative age error, which is here. Then you put a descriptive message here that you want to be displayed to the user. Okay, so this is your take home. You write a Python program that asks the user to enter a number, and the program should then ask the user to enter another number to divide the first number by, Then you should catch a value error if the input is not valid and display a custom error message like invalid input, please enter a valid integer. Should catch a zero division error, should use the else clause, so this is a little bit basic. So I hope everyone won't find issues with coming up with this. Okay. So finally, this is the end. This is the end of the Kab Python series. It has been a pleasure to share with you, and I hope you enjoyed. I hope you got to learn something. I hope you got to develop some few programming skills from this series. And the reason why we had this, we needed to have problem solving skills, try to identify problems that you can solve with the code. That's why we try to include in some real world examples that we had throughout our series. And we expect you to do it the same. Try to find real world challenges or issues that you think can be handled by a Python script. Like you see, the other time we were talking about the bank system. Most of those systems use Python, by the way. So when you're writing the codes, don't focus on cramming them, but focus on seeing how you can implement them to solve something as basic as maybe creating. Most of you, I'm happy you created your own calculators using a Python code. So that is something good, and I encourage you to keep finding more and more challenges that you can solve with Python. And that is one of the good ways you can improve your Python programming skills. Just daily or weekly, on a weekly basis, give yourself a challenge that this week, let me work on a Python program that tries to do this, Python program that does this, Python program that does this. And believe me, you will become good before you even notice it. Just don't stop at this, although we have stopped here for now. But don't quote me wrong, this is not the end of Python. Python is huge. You can still keep reading. I'll share materials in the group. I'll share different books you can read to enhance your skills even better. You can even be better than me and be just as good as you may want to, but just have to keep developing. So next we shall be covering the Kab AI series. That's what we shall be jumping into tomorrow. So tomorrow we already have that playlist up. We had our first episode last week, the one with mathematics and statistics. And tomorrow we are beginning off with pandas. And then we handle all those data science libraries before we do further hands-on machine learning and AI concepts. So watch out for that one and don't miss it too. And I encourage you to come up with the commitment just like you had in this series from the beginning up to this level. So if you haven't subscribed to our channel, please subscribe right now. Subscribe, comment, like, and yeah, that is it. You can also follow us on X so that you always updated to what we are doing. So these have been the Kab Python series, and my name is Simon. I've been taking you through with some other colleagues who have more so been appearing physically, but online it has been me. And thank you so much. See you in the Kab AI series.